at 6:15. And it's my great pleasure today to welcome Professor Pasachoff to give the public lecture at the Faculty of Science of the University of Hong Kong. And we have some anxious moments, and we're very glad that both Professor and Mrs. Pasachoff are here today because due to the severe ice storm in New York or northeastern United States, they had some adventurous moments trying to get from New York to here. But the good thing is that they are here, and my great pleasure to have Professor Pasachoff with us today, and he is the Field Memorial Professor at Williams College and in the United States, and also the Director of the Hopkins Observatory. Professor Pasachoff got his bachelor degree and PhD degrees both from Harvard University, and he is a world expert in the observation of solar eclipses. I think over the years, as I remember correctly, has seen 43 solar eclipses. Is that correct?
Before today, 44.
44, yes. By the way, the purpose of having him here today partly is because of the partial eclipse this morning, but unfortunately he wasn't able to make it to the Space Museum till this afternoon. So, and including, I think, the last and in Greece. Correct? So, and he is very much in demand as a public speaker all over the world on topics of eclipses. So, some of the topics that he will talk about today. And some of you also know that he is a well-known author, having published many very popular books. And I am told from some sources he is the wealthiest astronomer alive today, based on the royalties collected from his books. So we have to confirm that with him directly later.
Based on the honorarium.
Not from us, not from us.
That's the University of Hong Kong.
So just to illustrate that how successful an author that he is, and his publication of many books, including textbooks for astronomy students at the college level. So the topic that he is going to address today is, as you can see, solar eclipses and the transits of Mercury and Venus. And, Professor Pasachoff.
Thank you very much, Professor Kwok. I've known him for quite a long time now, and it's always a pleasure to see him in the United States and now in Hong Kong. I'm glad to be able to be here with my wife today in Hong Kong, and we got here just in time for the lecture, and I look forward to visiting more of your city again for me for the first time. For my wife, I was glad to be able to see a little bit of this little eclipse from the airplane today. Once we had this travel problem, I knew that we would be flying at 38,000 feet, which was a better weather forecast than we saw on the web for Hong Kong today. When I go to eclipses, I don't always go to the place where the eclipse is longest. We are often a week or 10 days in advance of the eclipse spot, and I choose the place with some eye for logistics and the big eye for weather forecasts. And I will shortly talk about the forthcoming total eclipses that I know you, most of you know about in China and other places in Asia in 2008 and 2009, but let me start by talking about the most recent total solar eclipse, which took place over a lot of Africa and Europe and Asia, and I will proceed. There are various vantage points from which to see the eclipse, and we, at the moment, are limited to the Earth looking up. There are weather satellites and sometimes people who are above looking down, and it is nice to be able to really see the eclipse cross right over the face of the Earth from weather satellites. The reason that I am looking at eclipses is to study the solar corona. This is a graph of the height above the solar photosphere, the visible surface of the sun, 1,000, 10,000, 100,000 kilometers. And this is the temperature. You see the temperature of the sun is around 6,000 degrees. And then all of a sudden it goes up by over an order of magnitude and goes into the millions of degrees. And scientifically, a lot of my research is dedicated to providing scientific measurements that help decide among theories that explain the million degree temperature. There has to be an injection of energy in some way that is not radiation. You know that when you go further away from a stove, it gets cooler, and you would be surprised if when you went away from your stove at home, you'd be surprised and afraid if when you went further away from the stove at home, it got hotter. But in the sun, as you go away from the source of energy in the sun, it gets hotter. So we're trying to resolve that problem. It has been solved. In fact, there are probably 15 people now who each have a different solution and say that they know the answer to the problem. And that, of course, means that we don't really have the answer to the problem. And some of my work is devoted towards getting the data that helps us to understand. To do that, we want to see the corona. This is a graph of the brightness of the corona. And here is the edge of the sun over here. And here is a typical sky in the desert. And here is a typical sky in Hong Kong. and the corona you normally can't see from the ground. If you go to a very high mountain, on good days you can see the very innermost part of the corona. But during the eclipse, the sun is blocked from hitting the sky. It is blocked from turning the sky blue, so the brightness of the sky comes here and we can see the corona to a considerable distance. Now, we are used to having the moon and the sun the same angular size in the sky. This is a fortunate coincidence because the moon is 400 times smaller than the sun, but it is also 400 times closer than the sun. And depending on where it is in its elliptical orbit, sometimes as much as 10% bigger or as much as 10% smaller. How many of you have seen a total solar eclipse? Very few. So I hope you will all get the chance. How many of you are planning to go to one of the next two eclipses in the mainland? Well, that's only half the people here. So the other half, I hope after the lecture, will try harder to go to see that eclipse. But we have this wonderful coincidence on Earth where the moon and the sun appear to be the same size, even though they're so very different in size. And then, just last month, we had this very unusual circumstance from a new spacecraft, an American NASA spacecraft called Stereo, and it's one of a pair of satellites from Stereo. And if this is the Earth's orbit around the sun, Stereo is, the two are going to go to different parts near the Earth's orbit, so it gets a stereoscopic view of the sun. And to do that, one of them made a loop around the moon to get it into its orbit. And so this is the moon. So this is an eclipse of the sun by the moon, what we would call an annular eclipse with a very big annulus, that took place on the 25th of February. It's a unique view in the history of humankind. No one has ever seen it like this. This is an X-ray image of the sun. In the background, we see some active regions on the surface of the sun. And here is a movie showing the same thing. Mm-hmm. Just incredible. I've never seen anything like that before. We could turn out some more lights, Cindy. Is that possible? So anyway, we are still looking at eclipses from various places. If you're standing on Mars and you can see phobos go across the surface. Thank you very much. The surface of the sun. The sun is a lot smaller when you get out to Pluto, for example. Charon certainly overhides the sun from Pluto, but here we have this usual accident where the moon and the sun are about the same size in the sky. And when that happens, we have a total solar eclipse. The most recent total solar eclipse started in Brazil last March 29th, went across Africa, and we observed it from Greece right here, and it went over Turkey and Georgia and Russia and Kazakhstan over to Mongolia, and then these are obviously the next two eclipses that are going to concern you over here over the next couple of years. I discovered with my wife in a museum a Portland map which the navigators used to have long ago. This is the 16th century, and this is the island of Rhodes in Greece, and this is the coast. So these Portland maps just followed what was at the coast for the sailors to navigate. And we went to an island here, which was on that map from the 16th century, from 1584, called Castellorizo, a very obscure island. It's the furthest east part of Europe that we chose to go to. I come from Williams College, which is here in the very upper left-hand corner of the state of Massachusetts, where 3 hours west of Boston, 3 hours north of New York City. We have an old college there. Williams College was founded in 1793, and we have the oldest observatory in the United States, which of course is now mainly of historic interest. And we do our work in the field, such as at eclipses. And I went with 6 students from my university to this eclipse, which crossed various places. Nigeria, as you know, is a very populated part of Africa, and I'm very pleased that as part of our working group on solar eclipses of the International Astronomical Union, we were able to work with scientists in Nigeria, especially Professor Pius Okeke, to get 400,000 eye protection filters to be distributed in Nigeria. And I hope to work with Dr. Kwok and other people to get the appropriate 8 million filters for the people of Hong Kong. There was one eclipse in Aruba, I think, in '98, where the local McDonald's had the filters for $1 or 10 Hong Kong dollars. So that's one thing you might look into. We went to this very strange little island, only 2 kilometers off the coast of Turkey. And it's a very rocky island, and only at the edge of the port was there any flat land to go to. They bulldozed a runway, and you go down the mountain and just into this port. It used to have 25,000 people 200 years ago when they built ships all around the Mediterranean, and now it's a very quaint little tourist town with a few local people left, just a few hundred people aside from the tourists. The path of totality went from Africa to Turkey, and we chose to be here and here's the island of Rhodes. I see I put the label in the wrong place, actually. This is Crete and this is Rhodes. I won't change the PowerPoint right in front of you here, but let me comment. You've all heard about the reclassification of Pluto. And were you there at the meeting? I was at the last meeting, and my wife was at the last meeting, and you can tell when you're having a meeting like that, and on the person at the podium takes the PowerPoint off and types corrections in, you know they're not really ready to pass this, but they passed it anyway. So anyway, here are the paths of the eclipses, and I'm going to talk about what we did at this one. The International Space Station passed overhead, and one of the astronauts there actually took this picture of totality looking down.